What's up, sunshine? Welcome to a special episode of CNN 10. Today we are focusing on one of the biggest issues facing our planet's future and the innovative ways one company is looking to tackle it. We're talking about energy. It's a crucial part of our everyday lives, but as the global population continues to grow, so does its toll on our planet. Pollution from our constantly increasing demand for energy has long been a key driver of the climatic and environmental disruption we're seeing. Greenhouse gases and other emissions are raising global temperatures, acidifying our oceans, and fueling extreme weather events. This has led scientists from around the world to focus on developing clean, sustainable ways to help fuel the future. And one of the minds behind this movement, Dr. Lonnie Johnson, right here in Atlanta, Georgia. We got an all-access look at how he and his team at J-Tech Energy are developing ways to turn waste heat into clean, sustainable energy. Dr. Lonnie Johnson is a man who needs no introduction, and his story reads like a movie script. The engineer, inventor, and entrepreneur rose from a childhood in a deeply segregated Alabama to become one of the brightest minds of his generation. He holds more than 100 patents and worked on nuclear-powered deep space probes for NASA and stealth bombers for the US Air Force. But he's also the mind behind one of the best-selling toys of all time, the Super Soaker.
Super Soaker MDS.
Gives water guns a whole new twist.
I've always been an inventor. I think we're all inventors. The human beings, creativity, problem solving, it's what we're built to do.
These days, he's turned his focus to our planet's energy crisis and the J-Tech, which stands for Johnson Thermoelectrochemical Converter. It creates energy using an incredibly unique technique that he hopes will help solve one of humanity's biggest issues.
A lot of the conflicts that you see in the world are centered on energy, oil. So if we could reduce our dependence on oil, we'd not only improve the environment, but we'd also have one less thing to fight about. So I think energy is very important.
But he's not doing it alone. He's got a whole team of bright minds helping make this a reality, and they're still pinching themselves that they've come this far.
Lonnie is an extraordinary scientist, engineer, inventor.
He puts on his lab coat and he wants to be in the lab. He's running experiments, he's trying to figure out the next big thing. I mean, Lonnie's a certifiable genius. His mind just works on a different plane. The idea of taking waste heat, geothermal heat, all this heat that comes out of your car exhaust, comes out of your chimney of the factory, if we could capture that and convert that directly into electricity at high efficiency, it truly could be a big solution to the world's energy needs.
Okay, you may be wondering how exactly this process works. That's where Julian Bell comes in. He's the VP of Engineering at J-Tech, and he gave us an up-close look at the process in real time.
What the J-Tech device does at its simplest level is it takes waste heat, basically the heat that's produced by industrial processes, and converts it into electricity at much higher efficiencies than competing technologies, at potentially much lower temperatures than competing technologies. You put waste heat in one side, electrical power comes out the other side. Do you want to see how we actually do that?
Yes, absolutely.
All right, let's go on around. So like I said, we're feeding waste heat into the J-Tech through this line here. The waste heat can be sent to one of the 1, 2, 3, 4 reactors that we have on this particular device. So what's happening right now actually is we are feeding waste heat into reactor number 3 here. You can see this light is on. This reactor here, which is full of hydrogen and is increasing in pressure, is pumping hydrogen out. This reactor over here, which is being kept cold and is sucking hydrogen in, is pulling that hydrogen back in. And that's how we close this hydrogen cycle to produce power.
So you're kind of using the same hydrogen all the time.
Exactly. That's what's critical here. That's how we manage to make this system work without having to add any fuel. All we're doing is pumping the hydrogen from one place to another place and then back again. So if the reactors are one of the two kind of core things that make a J-Tech, the stacks are the other one. Inside the stacks are the magic component, the membranes that make hydrogen fuel cells work. The hydrogen can't sneak its way through that membrane. So it has to do this really cool trick where the hydrogen separates into 2 hydrogen atoms. The hydrogen atoms release their electrons to become protons. And then at that point, those protons can wiggle through the membrane. The electrons, meanwhile, though, have to find their way back to those protons. And we make them go through a specific path to do that. We make them actually come out.
Still confused? Let's break this down even further. And science teachers, feel free to jump in and back me up here. Think of it like going through the security line at an airport. You're a hydrogen molecule, the electrons are your bags, and the checkpoint is the membrane. As your electrons detach and pass through a load, they create electricity. You become a proton and pass through the checkpoint, meeting back up on the other side to reform hydrogen gas. The process is repeated over and over, and the more heat you add, the faster it becomes.
So would you like to see this thing do something useful with the power it
Yes,
produces?
I want to see how waste heat was turned into something we can actually see.
Sounds good.
Or hear? What's this?
Yeah. This device here is what's called a boost converter. It's going to take the power that's coming from the JTech and boost it into a range that's useful to us.
Out of my man, with the mic in my hand. And we have a Tribe Called Quest. What?
All this water that's not even hot enough to make a cup of coffee, using that to generate electricity and throw a party.
Okay, so now that we have an idea of how this all works, where could we see JTech help create power in the real world? Turns out, one potential application involves something we've been talking about a lot lately: artificial intelligence. Tech giants are in a heated race to dominate the AI landscape and building thousands of data centers to do it. The Department of Energy has estimated data centers could consume up to 12% of US electricity by the year 2028. But our aging power grid may not be ready for the massive demand increase, and many households could end up footing the bill for power increases. Plus, not only do data centers consume a lot of power, they generate a lot of heat. JTech CEO Mike McQuarrie, or McHugh, says it's the perfect environment for a JTech to thrive.
The proliferation of data centers is almost unimaginable. AI drives a lot of it, of course, but
And they all give off so much heat, these servers.
So the heat isn't high, but the amount of heat is spectacular. So what we're doing is we're starting to work with data centers to figure out how can we put a JTech in the stream of that waste heat to create your own electricity, so you take some of the burden off of the grid. So the local community doesn't have to worry about, our power bills are going to go up because we're competing with that. There's going to be a scarcity. So I think you're going to see a big application for us in data centers going forward.
And get this, another perfect spot for a JTech has been hiding in plain sight, the byproduct of traditional energy production methods. The company says spent oil and gas wells, which are left behind once drilling operations end, present a perfect environment for a JTech to thrive.
All the oil's out, all the natural gas is out, but what's left is a hole that goes down a mile into the ground. At the bottom of that hole, geothermal heat. Constant geothermal heat. If you could extract that heat with a JTech, convert that to electricity, I mean, that's a game changer.
Okay, so we've learned what a JTech is, how the science behind it works, and where it could help our energy demand. But another key part of this mission is the who. We met some positively inspiring people during our time in the lab. Scientists, engineers, inventors, and staff members from all different walks of life coming together for a common goal. We asked them what advice they have for the next generation of bright minds who will tackle this crisis and how to not lose sight of the big picture. What's your advice to everyone out there who someday wants to be a CEO or an entrepreneur, something that you learned along the way that you know made you who you are today?
Yeah, I think a couple things. One is work at something that excites you. If you're not excited about it, it's hard to put your whole self into it. And then when you're at work, realize that it's important. What you're doing is important. And when you're there, learn from the people around you. I surround myself with really smart people. You can't be intimidated by people smarter than you. You need those people. It's exciting coming to work with those people because you're learning stuff every day.
I love that your team, all different walks of life, all individuals who bring their own strengths. They don't have to be able to do it all. They don't have to know it all. They rely on each other and they work towards a common goal, something that they're passionate about, and solving a really big problem, like finding better, smarter uses of energy, creation of energy that humanity is gonna benefit from.
Yep.
That's incredible stuff.
man. This is Santos Vagos.